The momentum of an object is defined as the product of mass and velocity, which can be expressed as P is equal to mv, where P is the momentum in kilogram meters per second, m is the mass in kilograms, and v is the velocity in meters per second. Now, momentum is a vector quantity, meaning it has both a magnitude and a direction. Therefore, it can have a negative or a positive value depending on its direction. So, if an object travels to the right, then it has a positive momentum, and if it travels to the left, it has a negative momentum. So, say there was a tennis ball that hit the wall, it's going to the right, so its direction is positive. The ball is now, once it bounces, the ball is now traveling in the opposite direction. This means that its momentum is negative. The principle of conservation of linear momentum states that the total linear momentum before a collision is equal to the total linear momentum after a collision unless the system is acted on by a resultant external force. The linear momentum is the momentum of an object that only moves in one dimension. The momentum before the collision can be expressed by m(a)(u)(a) plus 0, and the momentum after the collision can be expressed by m(a)(v)(a) plus m(b)(v)(b). Let's say the before has one ball with an initial velocity of UA, so its momentum would be MAUA, and there was another ball which is stationary, so since it has no initial velocity, it would just simply be 0. And the after, there's a collision that occurs, so the velocity will be VA. Notice how it's going to in the opposite direction, so it's going to have a negative sign, so MAVA plus the other ball, which now also has a velocity due to the collision of VB, so MBVB. This ball's velocity, however, may not always be 0, so just remember that the conservation of momentum is MAUA plus MBUB is equal to negative AVA plus MBVB.